Okay, here's our second video, or we could say part 2, working through the review problems for the midterm exam for Math 137. We're ready now for number 9. Now number 9, if you look at, you should have access to these problems also. They give us a triangle. Be careful, because actually normally when I do triangles, I make this my angle, but they decide to make this angle up at the top, the angle theta. And the problem is, find the value of each of the 6 trigonometric functions of the angle theta in the figure. So the 6 trig functions. All right, here we go. Let's do a quick review. First of all, let's do this. Before we do that, to find those, we need to know the lengths of all 3 sides of the triangle. I know the hypotenuse, the angle opposite the right angle, is 28. I know one side's 14. I need to figure out this bottom side. The Pythagorean, let's just call this x for now. Pythagorean formula says the hypotenuse squared equals the sum of the 2 sides squared. So if we solve this, get x squared by itself, let's see what 28 squared is. 784 minus 14 squared minus 196. So now if I want x, I have to take the square root. 784 minus, this is 588. I need to see if this simplifies. Hopefully you remember how to simplify square roots. In other words, you see if you can break this up into 2 numbers where one of the numbers is a perfect square. If it's a number I can take the square root of. I'm going to see about 4 to start with. As it turns out, I can have 4 times 147. Now just for fun, let me see if I can divide 588 by 9. See if it's a bigger number. Nope. How about 588 divided by 16? Nope. How about 588? How about divided by 36? Nope. One more. Divided by... Nope. All right. Maybe 147. Problems like this, it never hurts just to take your time, make sure of the math. Let me make sure I didn't mess up. 28 squared so you know what I did. Basically I said 28 squared minus 14 squared equals x squared. 28 squared is 784. 14 squared should be 196. 784 minus 196 equals. All right, so I'm trying to, since I'm trying to get exact answers, I can't make this into a decimal. So therefore, so I'm trying to make sure 147. Oh, see, that's it. You know what? It can be reduced further. 147 is 3 times 49. Square root of 49 is 7. So a 7 comes out. So now, if I redraw this triangle, 14, 28. This is a little tricky. to get the correct answer, you need to simplify this square root into 14 times the square root of 3. All right, so now let's do the trig part. They said the 6 trig functions. In my mind, there are really 2 really major trig functions, sine and cosine. Sine, I think of the little phrase so katoa, so, which is opposite over hypotenuse. So ka, adjacent hypotenuse. We can also do tangent. So katoa, opposite over adjacent. So now, for the sine, once again, be careful that the angle's up here, so the opposite is down here, divided by the hypotenuse. 1428 reduces down to, so that should be the sine. Cosine, so ka, adjacent, for this angle, 14 is the adjacent. Hypotenuse is 28. And then tangent, toa, opposite. Opposite's 14 square root of 3 over adjacent 14. The 14s cancel out. Now the other 3 are cosecant, secant, and cotangent. The cosecant is sort of paired up with the sine. And once you know the sine, the cosecant is just the reciprocal. You just flip the fraction. And by the way, you may have in the past learned that they used to tell us not to leave square roots in the denominator, but in this trig class, it's no problem. We don't worry about it. That would be the correct answer. Now cosine gets paired up with secant. Once you know the cosine, if you just take the reciprocal, then you get the secant. So if you flip 1/2, it just becomes 2 over 1, or just 2. And then the cotangent is the reciprocal of the tangent. So if you need to, we turn tangent into a fraction, square root of 3 over 1. If we flip it, we'd have 1 over square root of 3. Now when I look at the answers, I think in the My Math lab they'll take these, but if you want to be safe, you can always get rid of the square roots in the bottom. If I multiply top and bottom by square root of 3, I would have 2 square root of 3 over 3, and down here, multiply top and bottom by square root of 3, I'd have square root of 3 over 3. This is called rationalizing the denominator. You can check. I think it'll accept these answers, but when I look at the answer sheet, it's like this. All right, let's go to number 10. So number 10 says use definitions or identities to find the exact value of each of the remaining 5 trigonometric functions of the acute angle theta. And then they give us a trig function. So the first key thing is they say acute angle theta. Do you know what? It's important to know what it means, and it says acute angle. Acute angle means the angle is less than 90 degrees, or in radians. Another way of thinking about it is we could say it's quadrant 1. You know, we talk about the circle, the unit circle. An acute angle means it's going to be in here. That becomes important because in a minute when we go figure out our trig functions, the very last thing we do for all the trig functions is to decide whether the number is a positive or a negative number. That is determined by which quadrant we are in. Since we're in quadrant 1, since that's the acute angle, we know all of our answers are going to be positive. All the trig functions are positive in quadrant 1. All right, so that's settled. What they've told us is, for the angle we're working with, they give us one trig function. They tell us the cosine of theta is 1/10. Now you can solve this using identities, but the way I prefer to do it, I go ahead and based upon this information, I just create a right triangle. Now I'm going to put my angle down here. Cosine of theta, cosine, so ca, I can think of cosine as the adjacent side over the hypotenuse. And if I match it up here with 1/10, it's like A, the adjacent must be 1, hypotenuse is 10. If I go down to my triangle, if this is my angle, adjacent's down here, we'll call that 1, hypotenuse is 10, right? If I had given you this angle and said find the cosine of theta, you would say cosine of theta is adjacent over hypotenuse, 1/10. So in this case, in the previous problem, just to help you understand, they gave us a triangle and we figured out the trig functions. Now it's like we're going backwards. They give us one trig function and say, based upon this, figure out the rest of the trig functions. Well, the way I'm going to do it is I'm going to take the one trig function, create my right triangle, and now that I have a right triangle, I can go and easily find the rest of the trig functions. Now the first thing I'm going to do is I'm going to figure out the third side of my triangle. Now I explained in detail the last problem how to do that. So here, I know it's going to be 10 squared, which is 100, minus 1 squared, which is 1. So that side is going to end up being square root of 99. Although actually that's not simplified, because 9 times 11. So let me draw this again now. It's getting sort of messy. Hypotenuse is 10. This lower side is 1. And this side over here is 3 times the square root of 11. Now based upon that, I can easily figure out the rest of the trig functions. I already know cosine. Sine, so katoa, so opposite 3 squared 11 over hypotenuse 10. Not to simplify this here. I know the cosine. How about the tangent, so katoa, opposite over adjacent, which we would just write that 3 squared root of 11. Let me write the cosine here, although they already gave it to me. And once again, I know these trig functions are all positive. Normally a problem like this, if you're in one of these other quadrants, you have to make some of these trig functions a negative number. But I know here they're all positive. So now let's go find the other 3 trig functions. Once again, sine gets paired up with cosecant. So we just flip it. 10 over 3 square root of 11. So I'm going to leave it like this for now, and tangent, cotangent, we flip that. Once again, you can think of this as over 1. And then cosine gets paired up with the secant. If we take the reciprocal of this, it's just going to be 10. All right, so that's number 10. Number 11, now one thing about working problems in math, oftentimes there's more than one way to figure out the answer to a problem. And if they don't tell you to do it a certain way, then it's up to you. For instance, this one, number 11, says, write down the exact value of each of the 6 trigonometric functions of 45 degrees. So basically they're saying, here's a 45-degree angle, and they want us to write down the 6 trigonometric functions. Now for this test, you need to have memorized and know the unit circle. The unit circle gives us a quick and easy way to remember the trig functions of all the special angles. 45 degrees is one of our special angles. In my unit circle, I'll write it here, but I can do this in my head. I know 45 degrees is right there. I know that point, the x is square root of 2 over 2, and the y is square root of 2 over 2. Once I know the x and the y of that point, I can easily figure out all the trig functions. Right, because I know the sine is the y value of that point. So right away, I know the sine. The cosine of 45 degrees is the x value of this point. It's also square root of 2 over 2. The tangent is simply the sine over the cosine of 45 degrees. And we can look, since the sine and the cosine are the same, the tangent is just going to be 1. And now that we know those, we can find the other 3 trig functions from just taking the reciprocals. In other words, secant or sine gets matched up with cosecant. Reciprocal of this is 2 over square root of 2. Cosine gets paired up with the secant. It's also 2 over square root of 2. Cotangent is reciprocal. Oh, I should have said 45 degrees. Cotangent of 45 degrees. Wow. Not very hard at all, once you know the trig functions for that angle. Number 12 is another example of where, for me, knowing the unit circle makes the problem very simple. Now once again, these problems are, and I think it said, in number 11 it said exact value. Number 12 says exact value. That means you cannot go grab your calculator and use the trig keys on your calculator, because that will give you a decimal answer. That's not an exact value. So number 12, find the exact value of the expression do not use a calculator. In other words, they even tell you don't use a calculator. And the expression is 7 times cosine of 30 degrees minus 9 sine of 30 degrees. 30 degrees is one of my special angles. I can go, think about the unit circle. 30 degrees is my first angle here. And what's the x and the y of this point on the unit circle? The x is square root of 3 over 2. The y is 1/2. Okay, I have that memorized. You need to have it memorized before you take the test. So 7 times the cosine of 30 degrees, the cosine's the x value of this point, square root of 3 over 2, minus 9 times the sine of 30 degrees is the y value of this point. So I have 7 square root of 3 over 2 minus 9 halves. Since I have a common denominator, my guess is you could probably leave it like this or combine like this either way. That's the answer. What's the key to this problem? Knowing the unit circle, because these are special angles. If I know my unit circle, I right away know the cosine and the sine. Here's another one. Number 13, find the exact value of the expression. Do not use a calculator. Sine squared of 30 degrees plus cosine squared of 60 degrees. 30 degrees we have up here, the sine is 1/2. So what this means is 1/2, since it's sine squared, just so you know, we write it like this, but what that really means is you go get the sine of 30 degrees and then you square that number. So the sine of 30 degrees is 1/2, so 1/2 squared. Now the cosine of 60 degrees, 60 degrees is up here. The x and the y are 1/2 square root of 3 over 2. Since it's cosine of 60 degrees, it's 1/2, and I want to square it. So this is 1/4 plus 1/4 is 2/4, which is 1/2. All right, 14 is interesting because now they tell you use a calculator to find the approximate value of the expression, round the answer to 2 decimal places. So if they do not want you to have an exact value, they will normally tell you, and then you always will see the little phrase about how many decimal places to round off or to approximate. All right, they're telling you basically, yeah, it's going to be a decimal answer. And what they're looking for is the secant of 70 degrees. Now another way to think of the secant, since secant and cosine get paired together, another way you can write this is the secant is 1 over the cosine. So if I'm looking for secant 70 degrees, if I go to my calculator and find the cosine of 70 degrees, I stick it in the bottom of this fraction, then I can find the secant. So here's where you go grab your calculator. Now you gotta be careful, because your calculators, you can do trig functions in usually degrees or radians. For our problem, you gotta make sure it's put in the degree mode. So my calculator, I can see that it's in the degree mode. I'm going to type 70 for 70 degrees and hit the cosine key. And it's basically 0.3420. So now I take 1 divided by 0.3420, and I end up with 2.9238. Now I have to check what they want me to round it to. They say round it to 2 decimal places, which is right here. So I look at the next decimal over, which is a 3, which is less than 5, so this just stays 2. So the answer I would type in my math lab is 2.92. All right, let me see if I want to stop or do... Let's just do one more real quick. This is almost like a story problem. Maybe I'll show it to you. Find the distance from A to C across the gorge. So if you can see here, of course you can look at your own. They give us this distance, and they give us an angle 25, and they want us to find the distance from A to C. So basically what we have is just a right triangle. So if I wanted to, I could just draw this as a right triangle. And they're saying this side is 140 feet. And they tell me this angle is 25 degrees. And in a sense, they're trying to find the length of this side. So what you do is, based upon trig functions, I want to find the trig function that will relate this angle to this 140-foot side to the x side. If this is my angle, the x is the opposite. The 140 feet, the bottom side, is my adjacent. Which of the trig functions relates the opposite side and the adjacent side? So-called TOA. TOA is opposite over adjacent. So that's the trig function I can apply to this problem. So I can say the tangent of 25 degrees must equal the opposite of, which is x, over the adjacent, which is 140 feet. If I solve this thing for x, I basically get 140 times the tangent 25 degrees. And they say round to 2 decimal places, so that means I'm going to go grab my calculator. So I'm going to make sure I'm in the degree mode, enter 25 degrees, and then for me I hit the tangent key, T-A-N, and I take that, looks like it's 0.466, I'm going to multiply it by 140, so I get 65.283, since I say round to 2 decimal places, since I got a 3 here, it just stays. $65.28. All right, not too bad. So let's stop now and we'll pick up on the next video.